Hi, I'm going to go through the first half of the review in this video. I'm going to work through problems 1 through 6 on that first review. But before we start that, I'm going to go over just a couple of the logistics about taking the final. So you are allowed to use a 3x5 note card, front and back, cover however much you want to put on there. The Zoom link that I will send to you the morning of the test. You should get that in your email or your Canvas email. Then I will send you, once you're logged into the Zoom meeting, I will send you the Desmos activity code. And then each question will be in the Desmos activity on a different slide. So you work through the question, put in your answer into the Desmos activity, and then you do need to do all of your work on a sheet of paper like you would if it was an assignment or any other test. You need to show your work completely and indicate your answer carefully or completely. And then you will send me a picture of your work that I just talked about and your note card to the Canvas activity that I will give to you, that I have assigned to you. So if you have any questions about that, make sure and email me. So we're going to go ahead and start with number 1. It says the largest escalator in the US is 200 feet long. That's the distance people actually travel. So when you're on an escalator, you're riding up the hypotenuse of a right triangle. It has an angle of elevation, 25.15 degrees. How high is the top of the escalator above the ground floor? So that's that piece there. So since this is the side opposite and that's the hypotenuse, we'll use the sine. That's what our little equation looks like. And then multiplying both sides by 200. This is what we would type into our calculator. Now, making sure that your calculator is in degree mode because this angle is a degree angle. You should get 85 point. Let me use my calculator and see exactly what it is. Oh, sorry, 84.9979. But the question asks us to round to the nearest foot. So 85 feet. The second question talks about the Leaning Tower of Pisa. It leans at, so it says the Leaning Tower of Pisa was originally perpendicular to the ground. As a result of sinking into the earth, it now leans at an angle of 5.5 degrees from the vertical. So here's our vertical, and then it leans at 5.5. Now that's bigger than a 5 point, probably, whatever, from the vertical as shown in the figure. From the top, when the top of the tower is viewed from a point 150 feet from the center of its base, the angle of elevation, so now we have a triangle, is 53.3 degrees. Find how high the top of the tower is above the ground level. So the height we're looking for is actually this there. So that's made perpendicular to the base of the triangle at that height. So before we can even think about this, we need to think about the larger triangle. So if this is 5.5 and we subtract that from 90 here, this angle right here is 84.5. And then subtracting each of those from 180, we get this angle up here is 42.2. Now we can use the law of sines. The sine of 42.2 over 150 is equal. Now I could use the 53.3 and solve for this side over here, or the 84.5 and solve for this side over here. It doesn't matter which side you solve for. I'm going to solve for this one out here because this side over here is a little congested. So I'm going to solve for that side using the sine of 84.5, and then I'll call that x out there. And you can use whatever variable you'd like. You can name the triangle ABC and then so on and so forth. So x is equal to 150 times the sine of 84.5 degrees over the sine of 42.2 degrees, which is 222.279. Okay, so now what we're going to do is we're going to think about this right triangle. I'm going to redraw it right here, where this side is the 222.279. This angle right here is the 53.3, and the H is the other leg of the is the leg of the triangle, this one here. So since this is a right triangle, I can use the sine of 53.3 equal to H over 222.279. And so H and then it tells me to round to 3 numbers after the decimal unless indicated otherwise. This question does not indicate how to round, so we'll round to 0.218, 3 numbers after the decimal. That one used the law of sines, and if you need a brush up on how to use the law of sines, I have a video for the law of sines. Number 3 has a diagram with a triangle and 3 islands, island A, island B, and island C. The diagram shows the 3 islands in Florida Bay. You rent a boat and plan to visit each of these remote islands following the route shown. If you are on island A, on what bearing or angle of rotation clockwise from north should you navigate to go to island C? So think of there being a north-south line right here. And the bearing that we're looking for would be this angle here. So we're going to calculate that bearing by first finding this angle right here. So we're going to use the law of sines, or I'm sorry, the law of cosines. And we're going to use this one, since we need to find angle A. And so it looks like 7 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of angle A. 5 squared and 6 squared is 61. 2 times 5 times 6 is 60. Subtracting the 61, we get negative 12. And then dividing by the 60, this 12/60ths is just the decimal point, 0.2. So to find angle A, we would do the inverse. And you could just type in the 0.2 here, or you could type in the 12/60ths. It doesn't matter, whichever you prefer. We get the angle A is 78.463. Now, this is not our answer. That is this angle right here, right? What we need is the red angle I've indicated here, outside the triangle, the bearing. So since this makes a right triangle, we can subtract from 90, and that angle right there is 11.537. So again, I just subtracted this from 90 to get 11.537. Four has 2 parts. A silk fan. Actually, I'm going to do this. I'm going to erase all of this. Okay, a silk fan when opened completely, rotates through an angle of 140 degrees and has an area of approximately 83. Now, my picture is not to scale. Obviously, that's not a 140 degree angle, but you get the idea. The area is 83 square inches. And the question is, what is the radius of the fan we're looking for? So this is a sector. The fan is shaped like what we call a sector. The area of a sector is 1/2 r squared theta, where theta, the angle, has to be in radians. So in this case, our angle is 140 degrees. So to convert it to radians, we multiply by pi over 180. And I'm just going to go ahead and simplify that to 7 pi over 9 and leave it like that. And I don't want rounding error, and so I'll round at the very end. So we plug everything we know in. 83 goes here for the area. We don't know what r is, but we know the angle is 7 pi over 9. If you put the decimal for 7 pi over 9 in here, but you round out to like 4 numbers after the decimal, you should be fine. So then to get rid of the 1/2, we multiply by 2. And then again, if you have this number as a decimal, you would just divide it from both sides. R squared should equal 67.936. So R is 8.24. And the question says to round to the nearest inch. So 8 inches. Part B. Still talking about a fan. A silk fan, when opened completely, forms a sector with a radius of 6 inches and an area of approximately 15 pi inches squared. Again, we're going to use this formula, the area formula. What is the radian measure of the central angle of the open fan? So we're looking for the angle. So the 15 pi goes in for the area. The R is 6. This is 36. Times 36 is 18. And then when I divide by 18, I can simplify this to 5 pi over 6. The question says to leave your answer as an exact value. So you should leave it like that. Number 5 has 3 parts. It gives us the secant of an angle equal to 13/12. And it tells us that the angle is between 3 pi over 2 and 2 pi. So we know the secant of an angle is the hypotenuse over the adjacent side. So we can label a triangle with the 13 and the 12. This right here tells us that we're in quadrant 4. So I'm going to draw a picture. Here's my triangle in quadrant 4. The 13 is the side, or is the hypotenuse, so that goes here. The 12 is the side adjacent, so that goes there. Angle, reference angle goes here. So then using a squared plus b squared equals c squared, you should get a 5 for this side, except that we're in quadrant 4 and that's down in the negative y direction. So it's actually a negative 5. So part A is asking us for the tangent of the angle. And so the tangent of the angle is opposite over hypotenuse, or negative 5/12. Part B is asking us for the sine of 2 theta. And the double angle formula for sine is 2 sine theta cosine theta. So the sine of the angle would be opposite over hypotenuse. So negative 5 over 13. The cosine would be adjacent over hypotenuse, so 12 over 13. And then you just multiply straight across and straight across. And so 2 times 5 times 12 is 120. 13 times 13 is 169. Hang on, let me put this Okay, so part C is asking for the half angle for cosine. And the formula for the half angle for cosine is 1 plus the cosine of the angle divided by 2, all underneath a radical, with, don't forget your plus or minus right there. So we know the cosine is 12/13. So this looks like plus or minus, here, hang on, I'll move it down here. Plus or minus square root of 1 plus 12/13 divided by 2. So I'm just going to do a little side work over here. 1 plus 12/13 is the same as 13/13 plus 12/13, so 25/13. So we should have 25/13 on the top. All of that divided by 2. And so then dividing 25/13 by 2 is the same as 25/13 times the reciprocal. So flip the guy and multiply. This becomes 1/2. So 25/26. Now, whenever we have a fraction underneath the radical, we can take the square root separately. So take the square root of 25 and you get 5. But you can't take the square root of 26, so it looks like that. And then we need to rationalize the denominator, so we multiply by a square root of 26 over a square root of 26, and our final answer would be 5 square root of 26 over 26. So again, that's just rationalizing the denominator. Make sure that you do that. And then number 6 is asking us to solve an equation. The equation they're giving us is 2 sine squared x equal to negative 3 sine x minus 1, and it's giving us the interval of 0 to 2 pi. That tells us 2 things. We want the full unit circle, all 4 quadrants, and we want our answer in radians, not degrees. So we solve by first moving the 3 sine x and the 1 to the other side. 2 sine squared plus 3 plus 1. And then we factor this to 2 sine x plus 1 sine x plus 1. And we solve each of those little equations. 2 sine x plus 1 equals 0. Sine x plus 1 equals 0. And here we get the sine of x equaling negative 1/2. And here we get the sine of x equaling negative 1. Okay, so for this one, think of your 4 triangles, 1 in each quadrant. Sine is opposite over hypotenuse, so 1 and 2, 1 and 2. Here's where we get the negative 1 and the 2, the negative 1 and the 2. The 2 can never be negative, right? So these 2 don't count or don't work. These 2 are the 2 we want. But what angle is that? So the triangle with an opposite side of 1 and a hypotenuse of 2 has 30 degrees right there. The square root of 3 would be here. So that means this right here is 150 degrees. This right here is 210, and this right here is 330. So in order to answer this, this is 7 times 30, so 7 pi over 6. This is 11 times 30, so 11 pi over 6. So for this one, my answers would be 7 pi over 6 and 11 pi over 6. Let me erase this side of the board, and then we'll talk about the negative 1. So same idea. We need to make that negative 1 into a fraction, and so we would use 1 over 1. So in order for our fraction to be negative 1 over 1, here would be 1 over 1, here would be 1 over 1, here would be negative 1 over 1, or negative 1 over 1. Obviously, the hypotenuse can never be negative, so it has to be the side opposite. So again, these 2 don't work. So using our Pythagorean theorem, what's the other side of the triangle? If this side is a negative 1 and this side is a 1, the other side of the triangle has to be 0. So again, this is a visual representation for a triangle that doesn't actually exist. The adjacent side is 0, the opposite side is negative 1. That means it landed right here on the axis, and looks like the ordered pair 0, -1. That's the angle 3 pi over 2, right? 270. Okay, so that is the end of numbers 1 through 6. I'll include another video for 7 through 11.